In this video, we will learn how to derive the indirect utility function from the given direct utility function and the budget constraint. The question is, given the utility function of the consumer, which is a function of two goods x and y, which are related like this, u is equal to x times y, and the budget constraint of the consumer, that is the price of good x times of units of good x plus price of y times units of good y, should be equal to the income of the consumer. This is our budget constraint, this is our direct utility function. We have to derive the indirect utility function. Okay, so since we are being given this direct utility function, so our endeavor will be to maximize this direct utility function. U is equal to x times y. Why this is called a direct utility function? Because utility directly depends upon the consumption of two goods. How much we consume the two goods, so our utility will depend on that. Okay, so we want to maximize this utility function subject to the budget constraint that he is facing, that is price of good x times units of good x plus price of good y times units of good y should be equal to the income of the consumer. Okay, so to solve or to find out the direct utility function, what we know, indirect utility function, so we maximize this utility function subject to the budget constraint. And we know that how do we do it? So it is very simple. If we have good x on the horizontal axis, good y on the vertical axis, with the given budget, consumer wants to reach the highest possible utility function. I have told you n number of times. So first we need to find out the demand function for good x and good y. To find out that, we can use the tangency condition here. That is, at equilibrium, what will happen at this point where the slope of the indifference curve and budget line are tangent to each other, this condition, and let me write it here, this condition must set hold. That is, the marginal rate of substitution between good x and y should be equal to the ratio of the prices. Okay, price of good x upon price of good y. Now MRS, as we know, it is simply the ratio of the marginal utilities of good x and marginal utilities of good y, and it should be equal to the ratio of the prices, price of x upon price of good y, which implies MUX means the change in the utility due to the change in the consumption of good x, and MUY means the change in the total utility due to the change in the consumption of good y, and it should be equal to the ratio of the prices of good x and good y. Okay, having said that, now du upon dx means the partial derivative of this function with respect to x, partially differentiating this with respect to x. Derivative of x is 1, so we are left with y. Likewise, partial derivative of this function with respect to y gives us x in the denominator, and it should be equal to price of good x upon price of good y. Let us solve it for y. So y will be equal to price of good x, price of good y times x. Now we plug this value of y into the budget constraint, and our budget constraint is here. Okay, so that means price of good x times units of good x plus price of good y times the value of y, which we calculated as px upon py times x, should be equal to the income of the consumer. Here py gets cancelled. We have px times x, add them both, we get twice px times x should be equal to the income of the consumer, which implies x will be equal to, transpose this term, it gets divided, so we get m upon 2px. This is the demand function for good x. Likewise, to find out the demand function for good y, plug this value into this function, so y will be equal to price of good x times price of, rather upon price of good y times the value of x is m upon 2px. At this x and this x, rather px gets cancelled, we are left with m upon 2py. These are the demand functions for good x and y. Now to find out the indirect utility function. What is indirect utility function? Indirect utility function is a function of prices of good x, price of good y, and income of the consumer. That is, we plug the value of demand functions that we got here into our direct utility function. Okay, so in place of x we write this, in place of y we write this, and let me show it here. If I have the space, okay, I have the space. So x is m upon 2px times, so y is equal to, y we got somewhere, so y is equal to m upon 2py. So indirect utility function is px, which is a function of prices and income, will be equal to, so here we get m square upon 2 to the 4 px py. So this is our indirect utility function that we derived from the direct utility function and the budget constraint. So what does this tell us? It tells us that the utility is indirectly a function of prices and income. Obviously, since we know that direct utility, direct utility function is a function of the two goods consumed, but these goods are a function of prices. So this is price of x, this is price of y, and consumer should have some sort of income also. Okay, so we say that utility indirectly depends upon the prices and income. Why? Because the change in the prices obviously change the consumption of these goods. So obvious thing is that utility depends upon how much we consume the two goods, but the consumption depends upon what the prices of that very good is and the income. So we say utility indirectly depends upon the prices and income. I hope I make myself clear in this video. Thank you.